In this video, you'll be learning Python object-oriented programming. I have a playlist showcasing all the videos I did about Python OOP, so make sure to check it out after this one, because today we will cover everything you need to know to start with Python object-oriented programming. First, we need to understand that we use OOP to represent a real-world object, like a car for example. This car has attributes, like the name, and its behaviors, like it can go forward. A class is a blueprint that defines a set of attributes and behaviors that its objects can have. And an object is also called an instance of a class. This object can have attributes and behaviors based on the class they belong to. So every car object can have an attribute like name and a behavior like going forward. Let's see how we can write this in Python. Now to create a class, we will write the class keyword followed by the class name, which in our case will be car. And right now I will write pass because I will go right now and create an object. So how do you create an object? First, you need to store it inside a variable. I will declare a variable called car1, and to create an object you need to mention the class name followed by parentheses. And like this you create an object of car or an instance of the class car, and it is stored inside this car1, okay, which is our variable. Now let us go ahead and create a method, and a method defines the behavior of an object, and a method also is a function inside a class, so it is called method. Let's go ahead and create a method called move forward. So def move forward, and every method inside a class should have the self parameter, and I'll explain what it is later on. So this move forward will simply print moving forward. Okay, it is a simple method. And how do you call a method of a class? So basically you will use your object. In our case car1 stores our object, so I'll say car1 dot move forward. And so the basic structure is the following. So object name, which is car1 in our case, and dot method and method name. Okay, so now if I launch my code by hitting run, as you can see our car is moving forward. Okay, so now what is this mysterious self parameter? And why didn't we mention a argument for this self parameter? Or why didn't we mention an argument here in this parentheses? Well, let me explain. Basically, self is the object, okay? It represents an object. When we wrote this notation, we are indirectly passing our object, which is car1, as argument to the self parameter. So self in our case is equal to the object car1. So with the object name dot method name notation, you are indirectly passing the object as argument for the self parameter. An object can have attributes, also called properties, like a car can have a name, model, and color. To be able to give my object a name, a model, and a color, we will use a special method called init. Init is a method, but unlike any other method, its specialty is that when you create an object and hit run, this init method is called automatically. And let me prove it to you. First, let us write def init, and it is a special method, and we'll mention self here, which is the object. Let me go ahead and say print in init, for example. And look at here. And let me first of all delete this. And right here on this line, we created an object. And I said that init method is called automatically as soon as you create an object and hit run. So let us see. Is that true? It is true. So init was called automatically as soon as you create an object, car1, and hit run. But usually init is not used to print these kinds of messages. Init is used to initialize instance variables. So what are instance variables? They are variables that belong to the object. And these variables stores the attributes of the object. So how can we create name, model, and the color of an object? What we can do is mention them as parameters to the init method. So I'll say name and model and color. So because the init method is called automatically and the self parameter here is the car object itself. So it is the object. So what we can do here is pass the name, model, and color as parameter for init. And what we will do is mention the values inside the constructor. So let's say my car name is Audi, and the model is, let's say, R8, and let's say the color is black. So basically, as soon as I hit run, the init method will be called, car1 will be passed indirectly to self. So car1 is the argument for the self parameter, and these values are respectively the argument for these values. But now we need to store these values inside instance variables. All we need to do is say self.name. This is an instance variable that will store the parameter name. And so because we are now working with the car1 object, it is similar to saying car1.name equal to Audi. Okay? So let me write Audi correctly. Okay. So when you say self.name, this is an instance variable, it will store the value of name, which is Audi. Let's go ahead and create the instance variable of the others. So self.model equal to model. It is same as saying car1.model equal to what I said, R8. Okay. Let's do the same thing for color. So self.color equal to color, same as saying car1.color. Let me write it, and black. Okay. So these are the instance variables that store the value of name, model, and color of my object car1. And of course, each object you create will have an instance variable or instance variables, but of course they will have different values. Let's say I create a car2 right here equal to car, and let's say it is a BMW and M4, and it is red, for example. And so this car2 will of course have those instance variables, but of course with different values. So name will be, instead of Audi, it will be BMW. Here it will say car2, and here let's say BMW, and so on. You get the idea. And now what we can do here is I could say print car1 dot, and as you can see, I could access those instance variables. So when I say car1 dot name and hit the run button, as you can see, I will get Audi. And I could do the same thing for the others, so for model and color. Also, we can modify the name of our car by saying car1.name equal to, let's say, BMW. And right now, if I go ahead and print car1.name, instead of Audi, we will get BMW. But this is not a good way of fetching and modifying the data of our object. What we can do, and we will see it right now, is use methods called getters and setters. So what we can do is use methods called getters or accessor methods and setters or mutator methods. So a getter method is a method that returns for us a specific data, while a setter method modifies a piece of data. So let me go ahead and create a getter method for you. So let me go ahead and create a getter method. So I'll say def get name, and of course it should have the self parameter. What this getter method will do is simply return self.name. And like this, when I go ahead down here and say print car1 dot get name, this is how you access a method. And so if I go ahead and hit run right now, as you can see, we'll get the name of the car, which is Audi. So basically the car1 is being passed as argument for the self parameter. So here it is same as saying car1.name. And what is the value of car1.name? It is Audi, as you can see right here. So it will return the string Audi. So this is a getter method. Now let's create a setter method. So let's call it def set name, and set name will have self as parameter or the object and a new name for our car. So this method won't return anything, it will modify a piece of data. So what we will modify here is the name of our car. So I'll say self.name equal to new name. So I will say above this print statement, I will say set name. Let's say we want to change our car, and before I say set name, I need to say car1.set name, and I will set it or change it to BMW. So car1 is being passed as argument for the self parameter, and BMW is being passed for new name. So here, this notation is equal to of saying car1.name equal to, what is equal to BMW. So basically, we are changing the value of car1 that was Audi, and now it becomes BMW. So if I go ahead and run my code, as you can see, it was modified and it became BMW. So these are getters and setters. They are really important, and I recommend you to do a getter method and setter method for both of those instance variables. So make sure you go and do it. And now let's jump in to the concept of inheritance. Inheritance is an important concept in OOP. It is where a class inherits another class. And the class that inherits a class is called a subclass or child class. and the class it's inheriting from is called superclass or parent class. So in front of you, I have a class called father with an init method that initializes the father name and a getter method that returns the name of the father. I also have an empty child class, and I also created two objects, father and child. Now, how can this child class inherit the father class? It's pretty simple. Right up here, where there is the name of the class, we could mention inside parentheses the class that this child class should inherit, which is father. And like this, we just inherited this class called father. And so this child class is called the subclass or child class, and the father class is called the super class. So what exactly happens when a subclass inherits a superclass? Well, basically this subclass inherits everything or gets everything this superclass has, including methods and properties or attributes. So now let's go ahead and create or give this child a name. So what we'll do is we'll define an init method, and we know how to do this. It will take self, which is the object, and child name. Now let's create an instance variable that will store the child name. So self.childName equal to child name, which is the parameter child name. Okay, and now we need to pass here a name for child. Let's say Dave. Okay, good. But there's something missing right here. See, the object child is actually inheriting the father or the superclass called father. So when I go ahead and say here child dot, as you can see, it can access its own property, which is child name, but also it can access father name, the property of the superclass, and as well as the method of the superclass. But what we also forgot to mention here in the init of the child is that we need to re-mention the init of the superclass. And how should we do that? Well, we can use something called, or a method called super. And super is a special method that allows me to fetch or reuse the init method of the superclass. So each time you have a class that inherits from another class, you have to re-mention the init of the superclass in your subclass. So now I will say super.init. So I write init right here and say father name. But right now I need to mention father name or pass father name as parameter inside the init of the child name. And down here, I need to pass a value for this parameter. And what will it be? It will be the father name. What I can do and be smart with it is say father dot and get father name, which is a getter method that returns for me the father name, which in our case is John. So like this, I am passing John and Dave as argument for these respective parameters. And of course, self is the object, and we know that when we create an object and hit run, the init method is called automatically. Now super here means the superclass. It's same as saying father.init. Okay? So because father is the superclass, it's the same as saying the following notation. And so right now, let me go ahead and say print child dot, let us say get father name. So because child inherits father, the father class, it can use its methods. So I will hit run, and of course it will work because the child inherits the father class. And now I want to show you something else with the super method. So let me create a function or a method, that returns the info of the child. Okay, so let me go ahead and put inside the parentheses self. And now I will return here a print statement using an f string. I will say the name of that child is, and let's say inside these curly brackets, I will say self.child name, and I will mention here, and the father name is, and inside these curly brackets, I could use super to also access this getter method or this method inside the father class. So not only the super method allows me to access the init method of a superclass, but also other methods like this getter method. So I will say super dot, and where it is, get father name. So let me go ahead and say child dot and dot get father name. No, not this method, info child. And right now, let's go ahead, run our Python file. The name of the child is Dave, and the father name is John. Duck typing is a way to implement polymorphism, and polymorphism is where an object can have many forms. There's 4 ways of implementing polymorphism. We will start with the first one, which is duck typing. Duck typing is only known in Python because it is dynamically typed. Meaning, if I go ahead and declare a num1 variable here and store inside of it the number 12, right here on line 15, num1 is of type integer. But if I go on line 16 and say num1 equal to, let's say, true, a boolean, that will work because Python is dynamically typed. And so now on line 16, Python num1 is of type boolean. So this is dynamic typing. Now, duck typing is where we don't look at the type or class of the object, rather we only care about what it does or what is its behavior. So let me go ahead and delete this, and now in front of you you have 2 classes with the same method, which is called startEngine, and it prints engine started. And also, not to forget, I created objects of each of these classes. Now let me go ahead and create a function, not a method, a function outside a class, and this function is called turnEngine on, and it accepts an object. And now I will say object dot start engine. Okay. And now let me go ahead and call this function with different objects, with car1 first of all, and with boat1. So boat1. Okay, now let me run this code before explaining. So where it is. So as you can see, engine started, it works correctly for car1 and boat2. So what is exactly happening here? As you can see, nothing wrong happens, but this is actually duck typing. Why? Well, you can see here that object was before of type car, and then it became of type boat. But the program still worked normally, because we only care about the behavior, not the type of the variable or object. So because both of these classes have the same method or behavior, like startEngine, it allowed the program to work normally, and this is duck typing. Operator overloading is a way to implement polymorphism in Python. This concept allows us to customize the behavior of operators such as arithmetic operators and comparison operators. We know that we can add 2 numbers in Python, like let's say num1 or print num1 plus num2. We are here basically adding 2 numbers. But did you know when you say num1 plus num2, you're actually calling the int class, integer class, and this integer class has a special function, or method called add. And this add method takes num1 and num2 as parameter. So basically, when you say num1 plus num2, you are basically calling behind the scenes this expression. So int, the class int with the method add, that takes num1 and num2 as parameter, and both of them should return 3. Okay? So both of them works and add 2 numbers. But what I'm looking here to do is that first of all, I have this class grade, and I have grade 1, which is 100, grade 2, which is 90. I want to be able to add grade 1 and grade 2 together. So I want to be able to say print grade 1 plus grade 2. However, this won't work, and I will show it to you when I run my Python file. As you can see, unsupported operand types for plus operator with grade and grade, of type grade, of course. So what's going on here is that the plus operator is expected to have as operands integers. Instead of getting integers, it got a variable of type grade, or an object of type grade, which is this class. Because right here it is calling the int class with the add method, and it is passing grade 1 and grade 2 as parameters for the add function. And because those are not integers, they are grade, we are getting an error. So how could we fix this error? What we could do is define this add method inside our class and modify it. So let's see how we can do it. I'll delete this, I will delete this, and let's go to our class and say def and add. So it will take self and other. I'll explain what the other is. So I'll say now self.grade plus self.grade, it's other.grade, and let me return the output. So now if I say grade 1 plus grade 2, it will work. And look, we got 190. But what's going on here? So basically, because grade 1 is before the operator, it is the one being passed to the self parameter. So it is the object passed as argument to the self parameter. And grade 2 is after the plus operator, so it is the one being passed as per argument for the other parameter. And as you can see, self.grade means grade1.grade, which is 100, and grade2.grade, which is 90. So this right here is same as saying, let me however write it in a print statement, it is same as saying grade, we are calling the grade class, and using the add method, and passing grade1, and grade2 as parameters. And so if I go ahead and launch this file, as you can see, it works correctly. Let us say I want to also compare those two grades. I want to see if grade 1 is equal to grade 2. I want to be able to return both grades. Let me write both grades are equal. Okay. Else, if they're not equal, I want to write print. So both grades are not equal. So right now, if I go ahead and say 100 and 100, both of them are equal, but we are getting this message, which is both grades are not equal. What we need to do here is overload the equality operator by using a method called EQ. Okay, this is the method name. So what we'll do is go up here inside the class and say def EQ for equality, self and other. Now I will say return self.grade equal to other dot grade. Okay, so now this notation will work. Let me first of all run my Python file. As you can see, both grades are equal. And so right here, it is same as saying grade, the class grade dot equal to grade 1 and grade 2. So let me first of all cut this and paste it right over here to see if it will work, and it will. So both grades are equal. So this is operator overloading, and I encourage you to explore more operators. Like there is also the sub method for subtraction. So let's say int sub, and let me write sub correctly. So this is the subtraction method. Also we have the multiplication, which is mul, and we also have the division, which is div, and of course you can find them online. So make sure to overload these operators to train yourself about operator overloading. The last two ways of implementing polymorphism is method overloading and overriding. Method overloading is where a same method can be created multiple times, but with either different parameters or return types. Unfortunately, in Python, we don't have this concept because you cannot create different methods with the same name. But this is a program in C++, and C++ is one of these languages that support this concept of method overriding, or overloading. So this is where a method can be created multiple times, but it should have either different return type or different parameters. This allows for more flexible inputs. But Python supports another type of polymorphism called method overriding, and this is an important concept in OOP, and you are required to know inheritance here, and we already covered what is inheritance. So back to the father and son example. As you can see here, we have two classes. The class child inherits the father class, and this father class has one method, which is eat, eating a steak, and we have two objects right here, object of father and object of child. We know that when a class inherits another class, it inherits all the features like properties and methods. So this child class inherits this method eat, and it is the only feature that is inside this class. So this child class, if I go down here and say child object dot, as you can see, we could say eat, or we could mention the eat function, method. So the concept of method overriding is simply overriding the inherited method. In our case, the inherited method is eat. To override this eat method, all we need to do is re-mention it inside the subclass and change its content. So instead of printing, let's say, eating steak, let me print eating chicken and rice. Okay? And now, when I say child.eat, if I run my code, eating chicken and rice. So the child is eating chicken and rice, and the father is eating steak. And this is basically method overriding. It is where you override the inherited method. Child inherits the eat method from the superclass called father, and to override it, we will rewrite the name def eat and override what is inside of this method. Alright, this is the end. Make sure to visit this playlist about Python object-oriented programming, where you can find the other videos about Python OOP that I made. And now, I thank you for watching today's video, and I hope you found it valuable. Make sure to hit that thumbs up and subscribe to the channel, and make sure you click on one of these videos that will appear right now so I can be able to see you in one of them.